In this video, I am going to explain a Navy implementation of Navy Bayes algorithm. It is a popular classification algorithm that is based on Bayes theorem and assumes independence between features. Now, I uploading here packages for using import function. Here, I importing numpy, panda, matplotlib, .pyplot and Cbond. Here, the section imports the necessary libraries NumPy, Panda, Matplotlib, Cbond and several modules from sklearn. These libraries are commonly used for data manipulation and Matplotlib and Cbond are used for visualization and machine learning tasks. Here, I importing a trained split test function from sklearn model selection, and then I importing a metrics import classification report. And accuracy score and confusion metrics from sklearn. Now I uploading your data set here using read CSV function. This line reads a CSV file name Navy Bayes classification. Just copy the path and paste here. By running this code, the data set or read. I using head function to know the first 5 rows of our data set and using tail function to know the last 5 rows of our data set, and using shape, this line output the shape of the data frame data which gives the number of rows and columns. Isnull function returns a boolean data frame, name, data type and non-null counts. And info function provides a data types and non-null counts, and then visualization of our data set. Here I use a correlation function. This result correlation matrix is assigned to the variable correlation matrix. This line calculates the correlation matrix and visualize the correlation matrix as a heat bond using Cbond heat map function. This heat map is displayed using matplotlib show function. The heat map helps visualize the relationship between variable in the data. Now show the plots using plt.show function to view this heat map. Now I run this code. Here is the heat map for this model. And this code generates a scatter plot using Cbond, phased grid and scatter function. It visualizes the relationship between glucose and blood pressure variable with point color based on the diabetes class. This is a scatter plot diagram. Now we're splitting the data into train and test set. Here I store the feature glucose and blood pressure in X variable and target variable is diabetes. Here we know the absence and presence of diabetes. It is the target variable, so I stored the target variable in Y. Now I train and test the X and Y variable. X is our feature and Y is our target using train test split function here. Train test split function here. For x comma y, test size equal to 0.3. Random state equal to 0. By running this code, our dataset is trained and tested. Now I output the X train and Y train here. Here is the output for the diabetes. 1 represent the presence of diabetes and 0 represent the absence of diabetes. Now we implement the here I am importing a Navy base from sklan. This section implement the Navy base classifier, and the classifier is instantiated as model, and then the fit function is called to train the model using the training data for X train and Y train. And here this line uses a trained model to make prediction on the testing data and assigns the predicted value to Y prediction. Here Y prediction output the Y prediction output, our prediction output. Now I run this code. Here is the prediction for our data set. 1 represent the presence of diabetes and 0 represent the absence of diabetes. And then this line, now we prediction made by the classification report, output the classification report and the confusion matrix for evaluating the performance of the classifier. The classification report provides metrics such as precision, recall, F1 score and support for each class. The confusion matrix shows the number of true positive, true negative, false positive and false negative. And then accuracy, calculate and prints the accuracy score by comparing the predicted value with the true value. Overall, the code performance, data pre-processing, visualization, split the data into training and testing. Now we implement the Navy base. Now I see the accuracy score. Here accuracy score is 0.92. In this model, first we pre-processing the data and then visualizing the data and split the data train and test. Here we implement the Navy base and here is our prediction. And the last one is our accuracy score 0.92. Thank you.